haven't completed the entire match yet. How do you lose the game?
If you hit a bomb, you die.
So you're just playing?
All right, here we go. Let's look at circle T here. Angle BTA is how big? 52. So this arc is 52 degrees. Okay, we know that. What else do we know in this figure? We know this angle, right? Because this is a diameter, it goes straight across. The straight line makes how many degrees? 180. What's 180 minus 52? 128. Which makes this 128, right? Okay. Some other things that we know are all radiuses or radii of a circle are equal. So this is equal to this, which is equal to this, and all of the sudden, I have what type of a triangle is BTC? Isosceles. So we know by the isosceles triangle theorem, this angle is congruent to this angle. So how big are angles TBC and angle TCB? How big are those two angles? 26 each, right? They're each 26 degrees. Which brings us to what we're going to be talking about today. How does 26 degrees, I want this 26 degrees. How does this 26 degrees relate to 52 degrees? It's half of it. Get out your vocab sheets. The relationship between an intercepted arc and an inscribed angle, if this is 60, then this will be 30. The inscribed angle will be half the arc. But we need to write down the definition of an inscribed angle first. An inscribed angle has its vertex on the circle and its sides are the chords of the circle. So an inscribed angle has its vertex on the circle and its sides are chords of the circle.
What's the definition of chord?
That was from last time.
From Monday.
A chord is a segment whose endpoints are on the circle. Yes. Way to go, Carson. Way to support me.
I know Brad didn't, but that I'm good. Watch Beers Box videos. How do you know? No. Not the last one. I just make sure it's not going.
An intercepted arc is an arc cut off by the inscribed angle and lies to the interior of the two chords. So this is our intercepted arc, this red arc here. That's our intercepted arc.
Is there one more word?
Nope, not today. Secant is going to be on Friday. All right. What? All right. So angle ACB is 1/2 of the arc. That ACB is going to be 1/2 of the arc. That's what we need to know. So if arc DG is 45.6 degrees, how big is this angle right here? Well, might need a calculator on this one.
22.8.
Angle E is 22.8. How about angle F? 22.8. Which, if there are two inscribed angles that cut off the same arc, those two angles are, what's our magic word for saying they're equal to each other in geometry? So angle E is congruent to angle F here because they're both 22.8 degrees because they both cut off the same arc. An inscribed angle that cuts off the same arc are going to be congruent. All right. All right, so here's a diameter and a chord. And let's see what we got going here. Okay. So how much is it from D through G to H? How big is arc DGH if it's contains the diameter of the circle? How many degrees is that? 180. It's half the circle, right? Because the diameter cuts off a circle into two congruent pieces, so that's 180 degrees. Now, what does angle JHE look like? How many degrees does JHE look like? 90 degrees. All right. So what's the relationship between 180 and 90? It's half. So basically, a tangent and a chord will make the same relationship as an inscribed angle. Okay? So let's look at arc FGH. And I know I only need two letters there. Arc FGH compared to angle FHJ. How do those compare to each other? Well, the angle is what of the arc? Half the arc. The angle is going to be half the arc. Okay? So, if this is a 120 degree arc, the angle is going to be 60 if you have a tangent. Okay? So, BDE, angle BDE, this angle right here is 65 degrees. What is DFE? How big is arc DFE? Not 180, doesn't go through the center. 130 degrees. How big is the arc on the other side? This arc over here. How big is that arc going to be? 230, because they have to add up to 360. So this is 230 degrees. So what's this angle over here going to be? 115. Take 115 plus 65 once. What do you get? 180. You have a straight line. All straight lines are 180. See how this all starts to work together and make sense? Okay. So, a person is standing against a wall in a dark circular room with a diameter of 24 feet. The person has a flashlight with a beam 15 degrees wide. What's the longest length of the wall that can be illuminated with the flashlight. Okay? All right. So the longest that they can illuminate is if they go all the way across the circle through the center. So if the beam is 15 degrees wide, that means the arc is 30 degrees, right? So if the diameter is 24, this radius is 12 and 12, right? Okay. Now, to figure this out, this is a 30-degree angle here. And arc length equals the central angle divided by 360 times pi, or 2 pi r. So r in this case is 12. Okay, so if we divide this, 30 over 360 is 1/12, right? Times 2 times pi times 12. Well, these 12s cancel each other. 2 pi is like 6.28 feet. So the longest part of the wall that can be illuminated is 6.28 feet. Okay? That one is a little harder. Okay. So, a couple more examples here. If this is 86 degrees, what's this angle? Not 86, 43. The central angle would be 86. All the way across is 43. If this is 122 degrees, what's this angle right here? No, it's not 61. It's not 58, not the angle. Something in there is 58. 58 is this arc over here, right? Because that you took 180 minus 122 and you got 58. So then this is 29. See it now? Yeah, you did solve something. I'll give you that. Okay. So you ready to go on Savas already?
Yep. Yes.
The angle's half the arc. The angle's half the arc. You just got to remember that. Angle's half the arc.